In this video, we'll continue with the Ethernaut series and we'll see how we can solve the telephone challenge specifically. So let's jump right in and just read the description. So it says, claim ownership of the contract below to complete this level. Things that might help, see the help page above section beyond the console. So to get new instance, of course, click get new instance as always, and I think from now on we'll use the Guerli test network because all the others are deprecated with the ETH2 merge, and this specific level teaches us the transaction.origin phishing attack. So in this level we'll learn the difference between the transaction origin and message.sender. We'll see how you cannot use or you shouldn't use transaction origin as variable as a way to do user authentication, because contracts that use transaction origin as user authentication are exposed to a phishing attack, and this contract specifically does not really teach us the best way to understand this, and this is why I've created another contract that teaches us why that is also vulnerable to transaction.origin attack and will teach us in a better way, and it's easier to understand the attack itself by using this code instead of the one provided here in the Ethernaut level. But we'll of course solve this as well. So let's see first the difference between transaction origin and message.sender. How are these two different? Let me show you an image actually that shows the difference. So here we have an EOA account. If you didn't know, there are two types of accounts or addresses in Ethereum. First one being EOA, like for EOA stands for externally owned account. And then secondly we have contract addresses, basically contracts themselves. These are two types of wallets on Ethereum. And basically message.sender is an address referencing the most recent call. If you didn't know, let's say this is your account, EOA. You call one contract, you call a function, you interact with one contract. This contract interact with multiple other contracts. For example, contract B can call contract C, then contract C can call contract D, etc. etc. And basically, when you're accessing message.sender address, you're accessing the most recent call. So who called the most recent call? And transaction origin is different. Transaction.origin is the address that started the transaction. So for contract C in this example, to see the address of transaction.origin, to calculate the value, it has to traverse through the entire call stack and go to the beginning of transaction. Who started this transaction? And this is why transaction.origin is always an EOA address, externally owned account address, because contracts themselves cannot start a transaction. Only externally owned accounts can. And we shouldn't use transaction.origin because contracts are exposed to phishing attack if you use transaction.origin. And we'll see why in this code below. So for example, let's do this practice task to see the difference between message.sender and transaction.origin. So let's say we have contract B, contract C, and we have EOA. This EOA starts a transaction, interacts with the function A of the contract B. Then the function A calls the function B of the contract B. Actually, one function calls another function in the same contract. Then function B calls a function C on the contract C. A little question for you. What do you think the message.sender value is in function.a, as well as the transaction.origin value? So the message.sender in function A is of course the most recent call, which is the EOA. Transaction.origin traverses the entire call stack to find its address, basically who started this transaction, and we only have one call, so we only go one call back and we find out that it's the EOA. So EOA is both transaction.origin. So the transaction.origin and message.sender have the same value here in the function A. The function B is also the same thing, message.sender is the same thing as the transaction origin, which is the EOA. So the specific definition of message.sender is actually, I'll just read it out. Message.sender is the address of the contract or EOA that calls the first function to be called inside a contract scope. Because as you can see in this contract, we have two functions. We have function A and function B. So when you call this function, this is the first function, and here also the message.sender is the same thing. But what happens if function B calls function C? Then the message.sender will be the most recent call, that's the definition, and which is the contract B address. So the message.sender has changed. It's not the EOA anymore. So that's the message.sender. It's now contract B address. And what is the transaction.origin? Transaction.origin is now EOA again, because it will always be EOA, because this is the person, the account who started the transaction. Let's see now how by using transaction.origin we can hack a contract. So we have a wallet here, a contract that acts as a wallet. Some person, let's say, wanted to deposit Ether on the blockchain, specifically in this app, but he wanted to add some extra functionalities, so he just created a contract himself, where he is the owner, of course. The owner gets set in the constructor when you deploy the contract, so everything good so far. Message.sender is the most recent call, which will be his address because he will deploy the contract, so it's all good so far. He has a receive function in the contract because this will allow for the contract to receive Ether. This is a wallet, so he wants to deposit money here, and of course he wants to eventually withdraw all the money stored in this wallet. And here in the withdrawal, he will just provide the address to which he'll receive the money. Maybe he wants different address than the owner, and what we'll do is we'll just send all the balance in this contract. If the transaction fails, we'll just print out this message. So what this guy, the victim, has mistaken here, what he has done wrong, is use transaction.origin instead of message.sender. If he was using message.sender, the message.sender address will be the contract address, this attacker contract address. And this will fail because these are not the same. And you will not be able to steal the ETH stored in here. So you can deploy this, you can deposit money from one address and like simulate this scenario where one address, this victim stores, saves money in his wallet, then another, you can use another address to deploy this wallet, which I've already done, but my OBS messed up and didn't record, so I won't do it again. You can deploy this contract as well, and then what we've done here is we're just inheriting ownable the address that we deployed the contract with as the owner, and you can access this owner by using this owner function, which we also have in this ownable. And all we do is we save a contract instance of this wallet so we can call the withdrawal. And when we do, and it's important for you to send Ether to this contract and from this victim address that you deployed this contract with. And basically the attacker should do some social engineering, etc., perform a phishing attack on this guy, and he will send ETH to this contract thinking it was this contract, it was his wallet. But instead what he'll do is he'll call this contract, transaction origin will be his account, even though he called this receive instead of this, and the money are all going to be sent to the owner address. And what I've done now is I've developed a solution to the telephone challenge. I've just created this contract that stores an instance of the victim contract that I've deployed here, basically my instance. You can check this contract address by saying contract.address here in the console. This is that address in the console that you saw. Then I have a function solve level that I just called. This calls the change owner function with my address. The most recent call is my address, and now we should be the owner of this telephone after this transaction has finished running. How can we see this? Well, let's just say contract.owner, and we have an owner function here. So this is a promise, so let's use await. And as you can see, this is ends in F9, which is my address. So now I am the owner of this account and I've successfully completed this level. And I forgot to mention in the call itself, when we are transferring all the ETH, we're using the call function, which is the recommended way to transfer ETH in contracts. And here we can pass in two values mainly, I think, in these curly brackets after the call. We can pass in a value, which is the amount of ETH we want to send. We can also provide the gas. By default, the call method sends all the remaining gas that you sent when you initially started the transaction, all the remaining gas. But you can also change this and modify it. And the recommended way is to use call with re-entry guard, because when you send too much gas to other contracts, they can re-enter this function and potentially steal funds. And also, let me show you about what these brackets mean and what this empty string is. So here what you can do is actually you can use this call method to call another function of the contract. But this way, if you don't want to just call a function, you just pass in this empty string. And as you can see, we've successfully completed this level.